Hi everyone, welcome to 2.5 exceptions. We're just going to be learning about what exceptions are. This is something I wish that you would learn in another course because it's just another thing we have to teach. But the way the programs are structured means that you're going to come across these anyway, whether we like to hide them from you or not. So we thought we'd bite the bullet and actually just teach them instead. Exceptions in Python as a topic. What in the world are they and why does it matter? So exceptions are a topic about finding ways to deal with errors more robustly or more gracefully. In particular, it's like, what is an exception? Where do you interact with it? How do you handle it? It's like kind of a way, again, if you think about C programming, in C programming, you might typically do something like, you have a function that calculates the length of a list. And if there's an error or the length or the list is null or something, you just return -1. And that's kind of how you convey problems through like return statements. But in what would you say? Like with Python and most other languages, you often want to use something called exceptions to deal with that. So if we actually talk about what exceptions are conceptually, look at a bad example then a good example, it should mostly be pretty clear. So an exception, formally speaking, is an action that disrupts the normal flow of a program. This action is often representative of an error, and exceptions are things we can elegantly recover from. They're kind of like the opposite of something like asserts, where asserts kind of like just crash the program if something goes wrong. We don't want to crash the program if something goes wrong. We would like to, just deal with it and move on without crashing the program, because that would be very problematic for a person using the program. So if we have a look here, this is kind of like a C-style program in how you might deal with a problem. So you look at something like this, and you see what we've got here is we've got a square root function that we've defined with Python. If the input x, the variable inputted, is less than 0, then what we're going to do is we're going to call system.standardError .write, which is like saying print to the standard error output buffer, and then we're going to sys.exit1, which is saying like crash the program, because we can't deal with this negative number. We could maybe return a negative square root, but that's a bit weird, so let's just crash the program. And if there is no negative that we're trying to square root, simply return the number itself to the power of a half, which is the equivalent of a square root. Our actual program here is wrapped in an if name equals main block, which is saying only run this code if you're inside the main loop. And then on the next few lines, we say print enter a number. We read from standard input to get a particular input number, and then we print the square root of that input number, which we already converted to an integer, like that. What's the name equals main syntax for? That was covered, I think, in 2.3 yesterday, the third lecture yesterday, so you could probably go and check that out for that particular piece of information. So if we run that, let's go into 2.5, and we run exception 1. It says, please enter number 5. I get 2.2. Please enter number 9. I get 3. Let me get out of this virtual environment. For people watching live, the stream seems a bit choppy for some reason around 10 a.m. So I'm sorry if it's a little bit choppy. Naturally, the recording's totally fine though, so you can always watch that, of course. So I'm running Python 3 exception 1. Now let's see what happens if we enter a bad number, like a -5. If we enter a -5, it says error input less than 0, and the program crashes. That's not super elegant. We want a better way to deal with this. So this is where Python exceptions come into play. Now, immediately this is not going to solve a problem, but it's the building blocks of something more important. So instead of printing to the terminal, printing to the standard error on the terminal and then just crashing, what we're actually going to do instead is we're going to raise an exception. You don't need to import anything. This is like a built-in part of Python. Raising exception is saying, I want you, like when you say raise, what you're saying is, I want you to take something and start, screaming, saying there's an error, there's a problem, someone come and help me, and the program will stop executing and start panicking and looking for someone to help you out. So the only difference between this program and the previous one is that instead of printing to standard error and crashing, I'm now just raising this exception and I'm attaching some text to it. So a typical exception can actually have information in it, like a string that like conveys what's going wrong. So now when I run Python 3 exception 2, like this, and it says please enter a number, and I write 6, and then I write -6, it now actually prints a different kind of thing. So the program still crashes, but the reason it crashes is very different, and that reason is very important. The reason it crashes here is it's saying that there was an exception that was raised that no one handled. So when you raise an exception, as I said again, you're saying there's a problem, someone come help me, please help, and the program stops executing, starts looking for someone to help, and if no one can help, the program crashes, and it prints out what the exception was that it crashed with. You actually probably seen this happen in your own code. You've probably seen errors like attribute error, value error. You know, when you try and concatenate a, like what, print a plus 2. No, that's a syntax error because there's no type error. These are all exceptions. These are all these errors that Python's screaming out saying come and help me, and when no one helps, the program just finishes. You could actually manage these exceptions as we're about to here. So that's just throwing an exception. That itself doesn't do a ton for you because exceptions are all about throwing them, raising them, and dealing with them, managing them. So if we look at a more detailed example here, this is where we start working with managing exceptions. So we're still raising the exception in the first case, totally like the last example, but now instead of just printing a number here and trying to get the square root of it, what we've done is we've wrapped this code inside of what we call a try except block. Now it's kind of like, you know, an if statement in the sense of it's a command with an indent and then something else. But what the try except block actually has here is it starts with try, and anything inside the try indentation is saying keep an eye on all the code that runs in this area. If anything in this area throws an exception, I'm going to be watching it and we're going to be ready to try and deal with it. The second block here is your accept block. This is saying that this is how we're going to deal with particular problems. So try is look for a problem, keep an eye out while it's running. Accept is deal with it. More importantly with accept, you specify the type of exception that you are willing to deal with here, that you are ready to deal with. So anything that runs in here, if any code or code it calls or code that calls, anything in like the call tree throws a particular exception. When I say throws and raises, they're the same thing. It's just different syntax in different languages. Then we're going to deal with it. So obviously an exception gets raised here if someone types in a negative number. And then when it gets raised, try says, oh, there's a problem, stop executing. Let's jump straight to the accept block. And we can see that we're able to deal with exceptions. And this is how we're going to deal with it. We're going to print another message, error when inputting, please try again. And then we're going to take in another number. And then we're going to try and print it again. So we have a look at this. Please enter a number 6. Works fine. It doesn't, in this case, when you just enter 6, all it does is go print input number, print square root. It goes through the try block, but because no exceptions thrown, it just totally just finishes. It never gets into this accept block at all. So we run this, we enter a negative number. An exception is raised by the square root function, which means that the accept block catches it here. And then the code starts executing inside the accept block, which is, you know, print this and input the number again. So it says for another number, and I enter 9. And we got it okay. What happens if I enter -6, and then after it asks me for the new one, I enter -6 again? Well, it's going to totally crash now. And it's going to totally crash now because an exception was thrown in the accept block that was not dealt with. So then the question is, how do you deal with repeated exceptions, potentially? Right? Well, you could deal with repeated exceptions the same way you deal with most repeated anything. You use a loop. The answer is not to put more try and accepts nested in this case, because like that's like being a first year programmer and just putting like 10 if statements nested in each other. So we could use a while loop. Now, while true loops are not great loops, I acknowledge that, but it helps demonstrate the point. here. I mean, to be honest, it's not a terrible idea, but it's not my favorite programming approach here, but it conveys the point. So if we look at like the next example, you'll see that what we're actually doing here is we're saying please enter a number, and then while true, which is basically an infinite loop, we're getting a number from standard input, we're trying to print the number, and if we successfully print the number, we break. We quit the while loop and the program finishes. However, if calling square root raises an exception here, then what happens is, again, raising an exception stops the normal flow of the program. It halts. So if you're at this line here and you call this function and you get to this line, everything stops. You don't hit the return statement, you don't hit the break, you just completely stop there, stop what you're doing, and the way Python works is that it immediately quits the try and goes straight to the accept and sees if it can be dealt with. And when it gets to the accept to see if it can be dealt with, it actually prints out this message and then it goes back through the while loop. The way that exceptions more formally work, and this is something that might help you understand it, but you don't ever need to think about this deeply, is that exceptions stop the flow of program and immediately start popping off stack frames. They immediately start leaving functions without executing the rest of them until they find a particular block they're in where they're in a try, and then they try and match the accept, and if they don't, they just keep going. So it really is like a halt to everything. I'm screaming, help me, I'm looking, and you hope that something catches you, something has an accept blocked for you, you know, so that you can deal with it. Also, the program can deal with it. So this program now is a bit more robust, right? Python 3 exception 4. Enter a number, -6, -6, -6, -6. So it'll just keep doing this now until I give it a real number like 6, and then it will run and finish. I'm just checking what's left. There's a few other things here. So there was a question in the chat about what is accept exception as E here. What wasn't present in these, well, what was present in these examples is when you catch a certain exception, that exception actually has information in it. It has information like what the error is, for instance. And that error is defined by the string here. So if you want to actually deal with an exception and pass that error on to a user, you can actually write something like this, accept exception as E, where you're essentially saying, can you get me that exception object that you caught, and can I treat it like a variable E? So that variable E there will then get printed out, and that's why in these particular examples, it actually says error when inputting, and then this error here is what's being called, like input is less than 0, cannot square root number less than 0. This is actually coming from the exception itself. So that's why you'll see in this previous example here, it's like error when inputting, and then I want to print the exception message, and then I say, please try again, like that. You know, the flow of it's pretty, you know, it's doable. It can make sense. There's another example here, but where things get more interesting, and thankfully this used to be originally taught before, I think we might have done PyTest in the early days, so thankfully it's like we don't have to go through this again because it's already been touched on. But when it comes to the project, you deal with exceptions in the project. Like you might be catching exceptions, but in terms of the exceptions you throw, like the input error and the access error, you are typically in your project code going to be raising these exceptions. You will not be dealing with them much in your actual implementation. Where you'll be dealing with the catching of them is in your tests. So with your tests, you should probably expect to write a whole bunch of with pytest.raises, which again we've talked about in the introductory video to the project. With pytest.raises essentially expects certain code inside this block to throw an exception, to raise an exception. And if it does raise an exception, PyTest says, great, pass exactly what I expected it to do, which is good. The one thing to be cautious of here in this particular example, for instance, is that what this block says is that as long as one of these throws an exception, then this block passes, because what with PyTest raises exception really means is that I just expect the code in here to raise an exception. Not every line, just the code in here. So for instance, this is not a good practice of how to do this, because you actually expect all 5 of these to throw an exception, right? Not just any of them, you expect all of them to. And in the case where you expect all of them to, you should be breaking this up into 5 different little PyTest raises. So in this case, you should be doing something like this. That would be more appropriate here, because you expect them all to look up. Where can we look up named exceptions? Well, I mean, it's all in Python library. There's a whole bunch of standard ones that are built into Python, built-in exceptions. By the way, if Python just says 3 point something, it's going to be fine. I mean, you could go to the 3.7 docs, but here you go. You've got exception, arithmetic error, buffer error, lookup error, end of file error, import error, index error, key error, name error, OS error, value error. You know, there's a lot of different things. Zero division error. Like, I mean, this plays to the idea too that, you know, it's always good for your exceptions to be as specific as you can. The actual exception object is one of the broadest exceptions that exist. It could refer to everything, and generally we try not to use it. We try and use more specific errors. So for instance, if you were writing a square root function, not that you would, because Python can do that, you would use a zero division error for this particular error, because it's quite specific. Are there any more questions about exceptions here? I'm just going to talk about subtypes quickly, and then we can kind of wrap up and move on to the teamwork piece, last one for this week. So this last thing about exceptions is that without getting into the whole object-oriented background, which is quite a rabbit hole, the idea here is that some exceptions are kind of parents of other exceptions. They are like broader types. So you have specific exceptions like value error, import error, attribute error. And when you catch those, what you often want to do is you often want to catch the specific ones. So for instance, in PyTest except2, if I'm, say, for instance, raising a value error, which would maybe make sense in this case because the error is to do with a value that was inputted, like the value you gave is incorrect, then what you would typically do is when you catch it or when you test for it, you would be expecting a, you would be expecting a value error to be caught or dealt with like this, right? There are some exceptions though that are like cover others. So the exception is kind of like the mother of all exceptions. Every exception that you throw in the Python built-ins, like value error, attribute error, you can catch all of those just by catching it with exception. So exception's like a parent type, it's like a blanket type, for instance. And there's a bit of a complex relationship here between exceptions and like how they work, but generally speaking, what I'd say to leave you with is that you have a bunch of built-in exceptions which are quite specific, and then you have the exception, which is like all like if you throw any exception, you can catch them all with exception because it's again the mother of all exceptions. Generally speaking, though, that's not good practice because if you throw a particular exception, you want to have a particular way of dealing with it. So if you throw a value error, you should be trying to catch a value error. If you throw an attribute error, you should be trying to catch an attribute error. In the project, we have 2 errors that we've written for you, which is input error and access error. And the reason we've written those for you is so that you can get some practice in doing some more importing. We could have used some built-ins, we chose not to, but that's about the background there. So you don't need to define value error, they are built in. They are part of Python. Waleed says, are exceptions a dev tool or should they exist as a production code too? So exceptions are for production code. The way to think about exceptions is pretty simple actually. In a normal programming language, there's a whole bunch of errors that should be picked up at compile time. Syntax errors, type errors, a few other things. Exceptions are there to help you gracefully deal with errors that you can't predict at compile time. You can't tell when you're compiling code whether someone's going to enter a number that's valid or not. You can't tell when you're compiling code if a network request is going to fail. You can't tell if a database request or a file being opened is going to fail. There are many things that no matter what we do, we won't know until the program runs. Ideally, we want to know as much as possible until that point, but if there's a problem when the program runs, we use exceptions to gracefully handle these scenarios. Would the front end catch the exceptions in the project? Yeah, pretty much. So, well, sort of. But the short answer is, like, at the moment, most of what you're doing is just throwing exceptions in your implementation and testing the catching of exceptions in your tests. Can you define custom exceptions for the assignment? I mean, yeah, I guess. I don't know why they would be so useful. I'd probably encourage you to maybe post a short post on the forum with an example of what you want to do, just if you want to sanity check you're not wasting time or anything. But it would be great if you could leave some feedback. We'll wrap up this lecture on exceptions and then keep moving. So just pause the video if you're watching live, or if you're watching the recording, pause the video. I don't know if this is clear, but like if you're watching the recording a week later, you can still leave feedback here too. It's totally, you just follow the link. The link stays up all term, so super easy. That would be great. Anyway, thank you for listening on that one.